Hello everyone, my name is Dr. Satyanarayan Rao, and in this course actually I first time came across the K-Armed Bandit Problem. And one of the course exercises was they asked what is the similarities between supervised learning and the K-Armed Bandit Problem. Since I know a bit of supervised learning and I also learned a bit on K-Armed Bandit Problem, I thought why not make a detailed video on both of these techniques and similarities between these two and where they connect actually. So what do we have in the supervised learning is that we have a data set, basically the training data set, and what we have is that we have a lot of features, and these are actually the inputs in the supervised learning. These are actually measurable attributes. From these features actually we try to find a relationship between the input space, the feature space, and the target, which we can denote it as X and Y. The classic example is the popular Kaggle dataset, that is the Titanic survival prediction, where we have a lot of passenger characteristics like age, gender, and the class of travel as the input features, and the survival outcome is the target variable. So in a sense that it's basically the X and Y relation. In a simplest form, the correlation line we draw, linear regression, is the simplest supervised learning, where we have X and Y, we see the scatter plot, and we try to fit a line. This is basically what we are trying, but here we have a lot of X's. So this X feature is a vector, a lot of characteristics like the passenger, age, class, gender, and there is only one target, whether the passenger survived or he died. And so actually what happens is that we start with the labeled data. So in the training data set, we know that for each input vector xi, we already know what is the correct outcome y. But the goal here is to actually make predictions. So compare, the model learns the relationship between x and y, and it compares it with the ground truth, and then we adjust it to actually reduce the error. And there is some feedback that allows the model to actually learn better and better. And once this function is learned, we can use it actually to find y, or the target, for unseen data, so to make predictions. This is what all supervised learning is all about. So let's understand what is the K-Armed Bandit problem. So unlike the supervised learning, we had some input features and we had to train a model to predict the target. Here actually we don't have any input features in the basic setup. What we have instead is a set of possible actions that we can take. For example, A1, A2, all the way up to AK. So there are K possible actions that we can take. Each action, when we take, it leads to an outcome or a reward, we can say. So there is no target variable in strict sense as compared to the supervised learning. Every time we take an action, we get a reward. It's more like, you can think of it as the karma in the Indian philosophy. For example, for every action you get some reward. It's something like that. The idea in the bandit problem is to figure out which action actually leads to highest expected reward. And we only see the reward after we take the action. And for the actions we did not take yet, for example, there is no feedback from the system or from the reality. Whatever actions we take, we know for that action this is the reward. So in a sense that it's a partial feedback system. And understand it with an example. Let's say I have a room and I want to rent it on Airbnb website. Let's say since I am a photographer by hobby, I take different photos from different cameras and at different angles, and I test them. Like I put, like let's say this, I take 5 photos, and these photos I name it from A1 to A5, these are the different actions. Whichever photo I post it on my website or my Airbnb profile, I will see like the reward is whichever photo gets the most click rates. So what I do is I experiment. First I upload one of the photo taken from my favorite camera and I observe the number of clicks it gets. It's the reward system. And over time I noticed that some of the photos taken with some of the angle or some camera always gets more clicks as compared to my other photos. So naturally then I start favoring a particular camera or the top performing photo for my Airbnb profile. And from time to time I may also change the other photos to see if the trend has shifted because of other reasons like holiday, or if there are different set of audience behaving differently. So this is what actually I do in the Bandit problem. So one by one I upload the photo and then see its reward in the form of click rates. So if I compare now with this supervised learning, there are actually quite a number of similarities as was asked in my coursework, but there are also a lot of differences as I understand. The similarity is that in both cases what we see is that there is a model or an agent, we can say, is actually learning from the data, and there is also a feedback. Only thing is, in supervised learning the feedback is complete. We have the input features and the labeled target, and the model makes the predictions based on the true value of y, and it also learns to improve. But in Bandit what we have is that instead of features and target, we have number of actions that we can take, k number of actions, and for each action we have a particular reward which we can call it as r. And the agent or the model chooses an action that actually maximizes the award or observes a reward, highest reward. And gradually the model or the agent learns which actions are likely to give better outcomes or give us favorable rewards. So if we can think of like this, supervised learning has some input features, labels, and we find a function f of x that gives us y, where y is our the targets, x is the input features, and the function is the model that we are building it based on the training of the data, trained data. So in Bandit learning, the agent or the model has a number of actions that we can take. Each action is associated with a particular reward, and we try to maximize the expected or the average value of the reward. So we can see that in both cases the idea is that we use the past data to make better decisions for the future. But there are also some differences, like for example in supervised learning we have usually the fixed number of data set. For every feature vector x we have a target y that is already known in the trained data set. So we can directly measure how well the model actually performing because we know the ground truth. And the feedback is also very full and explicit because the ground truth is known. But on the other hand, in the Bandit problem, the feedback is limited. We can observe the reward only for the actions that we have taken, and we know nothing about the actions we did not even try. For example, I never know, like I have 5 photos of my room and then I know one of the photos is performing better, but if I have never tried other photos, I would never know how they perform. But in the supervised learning we have all the data at the first place, so we know that. This means that the Bandit problem is also more challenging because we have to balance the exploration, trying out different actions to gather information, and we have to explore which action gives us the best results. So if we can go back to the Airbnb example, what is supervised learning here is that we already know that which photo gets the most number of click. So I would just label all my photos with the number of click as the target. So this is a labeled data set. So we have 5 photos with the target as the clicked photo, like how many clicks each photo has. But in the Bandit case, we don't have that information upfront. I only know the clicks of the photo after I upload it onto my Airbnb profile. And so actually, to learn about other photos, I actually have to upload it and see how it collects the new data. So in short, like we have both, in both cases, it involves learning from the data. That's the common thing. And it also has some kind of feedback. The kind of feedback is different. Supervised learning gets the full information from the labeled data set, while the Bandit problem only gets partial information from whatever actions that we have already chosen. I hope you had some idea of Bandit learning and supervised learning. Thank you for watching so long, and I hope you enjoyed the video. I will come back with similar videos. Till then, enjoy life. Thank you.